Lab 5 is about digital circuit simplification. This lab, we will have two parts. First part is to construct an simplified circuit in your proto board. And then you simplify the Boolean expression, get the simplified circuit expression, and based on that, construct another circuit in your proto board and compare the two results. So how to simplify this? First, you see a long line above everything, then maybe consider De Morgan's law. Break the line, change the sign. And after you've done that, you will see you have two lines here and two lines here. Two lines means not. That means yes. So basically, because of the two lines over here, you can delete the two lines. So the circuit becomes this. And then we can continue use the De Morgan's law. So over here, you can break the line, change the sign. Same thing over here, break the line, change the sign. Break the line, change the sign. Then, after you get to here, consider to use the distributive law. Then that expression will become with the OR of three multiplications. Okay. And then continue. You see over here, say and say not. That becomes a 0. Then, don't forget, 0 and any variable is still 0. Here. And then 0 or anything is anything itself. So that's why this 0 can be gone. And then let's continue. For the term over here, let's first consider commutative law. So we can change the order. So B not and B and together, that will become a 0. And then 0 and anything is 0. 0 or anything is still that variable here. So finally, you got the simplified Boolean expression. Here is the simplified circuit truth table. How to derive the truth table? First, we have A, B, C, D, 4 variables. Think about how many different combinations the 4 variables can create. That will be 2 power of 4. So that will be 16 different combinations. That is actually binary counting from 0 to 15. So to fill in this table, we can go step by step. First, figure out what is A naught. That is just invert the first column, and same as B naught and D naught. And then you do a AND logic. That is A naught and B naught and C and D naught. So this is the truth table. From this truth table, you can see there's only one row. The result is 1. So now let's see how to construct this circuit. This start with unsimplified. So how to construct the unsimplified logic circuit on your proto board. Based on the expression here, you can see what gates we need. We need a NOR gate, NAND gate. And here is another NAND gate. Here you can see it's another NOR gate. And overall over here is another NOR gate. So basically, we only need two types of gates, NOR gates and NAND gates. NOR gates, we will use 74LS02 IC, and the NAND gates, we will use 74LS00 IC. And the pin diagram is listed over here. Pay attention to which pins output, which pins are inputs, and also don't forget you need to connect the ground and the VCC for each IC. And so based on that, seems like we need 3 NAND gates, NOR gates, and 2 NAND gates. And since in each IC you have 4 gates, you can actually pick up whatever gates you like to use. So here we use for NAND gates, we use this one and this one. For the NOR gates, we used this gate, and the gate located over here. And my suggestion is when you sketch the circuit diagram, you better label the pin number of IC on your diagram. That will make things much easier to identify. From here you can see, I spent some time on this circuit and figured out why they connected like this. And then how to test this circuit. You have 4 inputs, A, B, C, D. Don't forget in Unit5Lab, you build the inputs part and actually also the outputs part. Remember, you connect Y to one output circuit, and that LED will indicate the output is 0 and 1. In Lab 3, actually, if your LED has light, that means you have 1 in the output. If the LED has no light, that means a 0 showed here. And for the input set, please review Lab 3 to see how to get a 0 and 1 on ABCD. In this slide, we listed the pin connections of each IC. The circuit on the left and on the right is exactly the same. But on the proto board, your circuits will be more like the circuits on the left. Here, talk about, for example, the A connection actually to AC, A connected to pin 2 of 7402. So A connect to pin 2 of 7402. Similar thing you can see. B input connect to 3 of 7402 and also pin number 5 of 7402. So you can see B connect to 2 pins. One is pin 3, one is pin 5 of 7402 IC. And for example, over here you can see the pin 6 of 7400, pin 6. Let's find 1, 2, 3, 4, 5, 6. This one is pin 6. Connect to where? Connect to pin 8 of 02. So connect to pin 8 of 02. Don't forget how to count an IC's pin number. That is counterclockwise. 1, 2, 3, 4, 5, 6, 7, and 8 is over here. 9 will be over here. So based on this, basically based on this circuit, you should construct your circuits like this on your proto board. And then ABCD connected to input circuits you build in Lab 3 and output circuits to the output circuit in lab 3. Then you can test the circuits to see the circuit output is the same as the truth table you derived or not. For the simplified circuit, the Boolean expression is output equal to A0 and B0 and C and D0. For the NOT logic, we use NAND gates and short the two inputs together to represent a NOT gate. We talked about it in class already. And then you will see if here's A, then after inverter you should get an A0. So here's a B0, here is C itself, and here is D0. And then after the gate, the AND gate over here, you should get A0 and B0. After this AND gate over here, you should get C and D0. And then you put another two inputs AND gate that will AND this group and this group together. So that's why finally you will get those four variables AND together. So similar things, you can see what kind of ICs we need. We need NAND gates and AND gates, so two types. And NAND gates is 7400, 7400 pin diagram is listed here. 7408 is the AND gate, and the pin diagram is listed over here. So over here you can see this is a 7400, pin 1 and pin 2 shorted together and connected to input A. And also look at here, for example, this is a pin number 6 of 7408. So if you count 1, 2, 3, 4, 5, 6. Connected to where? Connected to 7408's pin number 10. So this one goes this way all the way to pin number 10. So pay attention to the pin connection and also be patient. Which circuit do you think is in simplest form and why? Consider this. And then don't forget to download your lab instructions. Follow the instructions, finish your lab, and submit lab report.